Yeah.
Okay, thanks, Harsh. So, hi everybody. This is Vikas this side. I'll be taking today's session on fundamentals of programming in C. So, before proceeding further with the new topic, I would like to start with the questionnaire on the previous topics, whatever we have discussed in the last session. So, you can raise your hands or put your questions in chat, and we will take questions first. And after 5 minutes or so, we will start on today's session. So, do you have any questions? Please raise your hand. I don't see any questions. Well, I think we can proceed further.
Yeah. Okay.
Okay, so today's topic is arrays. We are going to talk about arrays and a few related topics. So before starting with the arrays, we need to understand why arrays, why we need an array itself. What is the concept of arrays is secondary. So in previous session, we talked about various topics like iterations, conditional structs, constants, and variables, right? So in variables, when we discussed that variables are kind of placeholders to carry a value. It could be of any type. It could be anything which is kind of usable to the application. So what is the normal format we use when we declare a variable or when we have a variable in our application? It is mostly of, let's say for an example, it is an integer. So integer a denotes a value, right? Integer b denotes a value. So basically we are denoting two values here. So let's say if I want to have hundreds of values, how exactly I'm going to keep them? I cannot assign a single name to a single variable or a single value, just like variables. It is very difficult. I cannot do that. So as a solution to that problem, we have a concept which is known as arrays. This is a data structure, we can say, a primary data structure, which is almost available in all the programming languages so far, all the modern languages. So just to get an idea of what an exactly array is, I can quote you an example. You might have you might be aware of the DVDs or CDs, right? In which we used to store information, especially movies. We have a concept of VCR earlier, and then after that we had a concept of CD and DVDs. Those were small disks which contain a lot of information, around 700 MBs of data, or maybe a few GBs sometimes, right? So let's say I want to have a collection of movies stored in a DVD. So how can I store that? I need something to keep it safe, right? Let's say I want to arrange all those DVDs, whatever I have in my collection, at a particular place so that I can quickly go to that place, identify whatever is needed, and fetch that and use that. So in that case, the possible option could be just to have a drawer or just to have a cardboard box where I can store all my DVDs, right? So in that way, what is possible? I have a place, let's say cardboard box, or maybe a drawer. So that is a pre-decided place that whenever I have to get an access to a DVD, I have to go to that particular drawer, right? This is a kind of storage for that DVD stack or DVD collection. So one more thing we will keep in mind, that means as we are trying to keep all the DVDs together, my intention is to keep those DVDs only. We will not mix any other stuff with that collection, right? So that is a cardboard or drawer specific to DVDs. I'm not going to put any of the other stuff, maybe pen, pencil, books, anything other than that into that. Okay, so that is my intention is. So basically, if you see, all the DVDs share a common property or a few common properties. Let's say if we talk about a particular DVD or a DVD collection of movies, so in that case every DVD is having a name, the movie name, right? Or maybe the feature could be something like the storage amount, means what exactly we can use within that DVD if it is not a movie. So similar to that, everything whatever we are going to put into that stack, that collection, is having a property, and that property is shared by almost every object, right? So similarly, what happens if I want to keep data, a huge amount of data, at a single collection? So defining the variables, each and variables is not possible. Defining a variable and accessing that a variable is a huge cost. I can't remember names of each and every variable. Let's say I have 100 variables, so I cannot give them 100 names, 100 individual names. So I use array. Array is similar to that collection of DVDs where I am storing a particular type of data. And all those data, whatever I'm storing within that array, shares common properties. Let's say if I'm saying that it is an array of integers. So in this case, this particular array is going to store only integers. It will not store any other data type. Let's say I'm saying it is an array of characters. So it is going to store only characters, not any other data type. So this particular storage block or collection of a particular type of information is known as array. Okay. And if we talk about the definition of array, the bookish language, it could be defined as an collection of items. Okay. And the items could be integers, strings, DVDs, games, books, or anything which is feasible to store, or anything which can be described in some properties. The items are stored in neighboring or contiguous memory locations mostly. That is, as we discussed, right, in a collection of DVD, we don't have any other item in between. If first index or the first object within the drawer is a DVD, the second is also going to be DVD. The third is also going to be a DVD, that way. So similar to that, when we talk about an array, all the elements in that particular storage block are going to be of same type. If it is integer, it is integer. If it is a book, it is a book. If it is a float variable, it is float. If it is a character, it is a character, right? So as we can see that these things are stored in contiguous memory locations when we talk about array. So the entire collection is easy to access and straightforward. We don't have to worry about various things, how to go and identify a particular object, and all that part can be taken care of very easily, because we know that if we have to find a particular DVD, we have to simply go to that particular drawer and fetch the information or fetch the DVD, whatever we need, right? We don't have to look into house or into other places within the house, right? So let's talk about how can we create an array, right? So before creating an array, we need to check how exactly we created a variable earlier. I'll show you that part. Okay. So let's say this is a application, a sample application where we are going to talk about all those things and see how things are working. So this is how we used to declare a variable so far of type integer. Now let's say I want to consider it a collection. How can I make it a collection instead of an individual variable? Simply I have to put square brackets. Now this is an array. Let's say I'll change the name also just to keep it relevant. So now I can say that this particular variable named array is an array or collection of integers. This is how we read it. Or let's say we make it easier and relevant to our application. So DVD is an array of integers. This is how we declare a array. And we talked about one thing, that all the elements are stored in a contiguous memory allocation, right? So what exactly that means is, just a second. If you look into this representation, the blocks that we have within the screen, right? Integer ARR 10. So here what we are doing, the 10 is the size of array, number of elements that we're going to store within that array ARR. So according to this particular declaration, what it defines is ARR is an array of 10 integers, right? And this is the block of memory representation, how exactly it is, it can be referred within the memory, and how can we store the elements actually. So if you look into this block, you see that every index or every box represents a particular location. Let's say DVD1 is stored at 0 position. Okay, DVD2 is stored at 1 position. DVD3 is stored at 2 positions. So all these are contiguous. There is no other different type of data available in between. This is a complete block, whole and complete, which is going to be dedicated to this particular type of data only. So this is contiguous memory allocation for the arrays. And this is also the memory representation of an array. In a similar way, whenever we talk about an array, so it is a contiguous block, right? So whenever we do int ARR 10, so what exactly we are doing? We are defining this block of memory for 10 integers, and we are having access to first element of it, or the address of the first element, that is ARR of 0. So this is the memory representation of an array in memory. Based on the type, let's say right now we are using integer. It is, every block is of size of integer actually, but let's say we don't have type of integer in our program. We have DVDs, an object DVD, right, which could be a structure in C. So it is going to be size of that structure. Accessing elements of an array. How can we access elements of an array? That is what we are going to talk next. So basically, when we talk about element operations or array operations, we have two operations, that is writing an element into an array or reading an element in an array, right? So let's see how it works first. So this is an array that I have declared for integers. What I'll do, I'll simply put a value into that. This is how we put a value into arrays. What exactly I'm trying to do is I'm referring array, that is by the name of the array ARR, then the index value 0. What exactly the index value is, we'll talk in a bit. And then I'm simply assigning a value, just like normal variables. Let's say I have a normal variable int x. Okay, so in that case, what I would have done, I would have done x equal to 4 for an example, right? So similarly, what we are doing here, we are simply doing this. ARR of 0, 2, ARR of 1, 3. Basically, these are the positions that I want to put the element at. So when we talk about arrays, everything is related to or accessible from a name. That is the name of the array. So how exactly we identify that particular thing, particular element of it, right? That we need to look at. Before that, let's say I have done this. ARR of 2 is equal to 4. And I'm doing ARR of 2 again is equal to 5. So what do you think? What should be the value? What should be the stored value within second position of the array now? Any answers?
Five. Maybe it will give
5, sir.
And why not 4?
Because it will what rewrite, overwriting.
Okay. Okay. Fine. So we'll proceed further. This is how we put the elements, right? Let's say I want to get the elements. How exactly I can get? So this is again similar. We have to use the name of the array, the position from which I want to get the element. That's it. So basically what I'm trying to do here is I'm going to store value of element stored at second position in this array at x. Okay, this is what my intention is. But actually what happens if I'm pushing 2 here? So I'm not getting the second element, I'm getting the third element. Why? This is what we are going to talk in a bit.
So I have one doubt.
Yeah, please.
So we haven't talked about that index yet, but I have doubt regarding that. That like
I'm going to talk that now.
But I wanted to ask.
Okay, please.
Like you are telling that this is x will store the third element value in array.
No, X will contain the value whatever is available at third element of array.
Okay, and this will be array of third element. ARR of 2 will represent because the index will start through 0.
Hmm.
So here that in line number 9, can we start with the 1 and will it work like array index of one element and
Yeah. See, if you look into the line number 5, what I have done, I have declared a variable ARR, which is a size of 10, right? So up to 10, I can use any of the indexes. 0 to 9 is fine. I can put any random index and I can use that because this is something which is pre-allocated to me. I am authorized to use that. Let's say if you talk about in the context of that DVD drawer, right? So let's say I have 15 elements or I have a capacity of storing 15 DVDs within that. I can store my DVD at any position, right? As soon as, I mean, as far as I know that it has a space, I can put elements. Correct?
yeah, sir, but my question is if we means start our array like instead of giving ARR of 0 from there starting with ARR of 0, if we can start with ARR of 1 and then we wanted to means move.
Okay, your question is why every time index starts from 0 and not 1, is it?
Yeah, if we are initializing index with 1 and from there we can take 10 like that.
Okay, no problem. I'm going to talk about that particular thing in a while. I'll explain that.
Okay, thank you, sir.
Okay, okay. Any other questions so far?
So one question I was having with the last assignment, that playing with character, I guess.
Mm-hmm.
And sorry because I was a bit late. I joined a little bit late.
Okay, so
That's
in that
why.
case, it is okay if I can take that question later after today's session. It may be at the end of the session with other questions.
Yeah, sir, I was waiting.
Yeah, just don't want to lose the context.
Sorry, sir.
Okay, thank you.
Thank you.
Okay, so when we talk about arrays, so we usually get to know that arrays are efficient data structure. Why exactly arrays are efficient data structure? Any guesses? No one?
Because we can
Because
access
data is stored in
values easily.
sequential manner, sir.
Okay, so what?
Because retrieval and storing the value is easier, much more faster.
Amartya, your voice is little bit low. Can you bring the mic closer?
So basically, it's like that. We can retrieve the elements and store the elements more faster than others because it don't have any relationship between like that. Because in linked list there we have to assign that head then next node like that. In this it is continuous, so it will be we can directly access the index and store it.
Okay, fine, Amrit. Any other answers?
Sir, we know already its length and we can access easily.
Okay, it depends on the implementation whether we know the length or not. Okay, okay. So we know that we have direct access to elements using indexes, right? So this is one thing which is the advantage of arrays and allows us to have a quick access to a particular element or a random access instead of having a sequential access, just like linked list. So if you relate it to linked list, let's say I have to fetch the element at third position. So in that case, I have to start from the first node, that is the head of the linked list. I have to parse all the elements up to 3 and then I can access the third element, third node and element of that, right? Value of that particular node. So this is not needed in case of arrays. We have indexes, and putting indexes in place, we can simply access any of the values as far as this is a valid index available in that storage, right? So basically there is um, another question arises: how exactly index helps in fetching the values randomly? Because if you check, if you look into the declaration of an array, we have only a name, which is the position of the first element in that particular allocated memory, right? How can I access, let's say I have an array of 10. I want to access fifth position element. How can I access it directly? There must be some rules that might be followed, right? So here comes another concept. Why indexes always start with 0, as asked by Palak, I guess, right? So there is a reason why we have indexes starting from 0, because it eases the calculation of the address of a particular element using index. So how exactly that is being calculated, let's talk about it. I'll clear this for a while. Okay. So let's say I have an array of 10 elements here, okay, and ARR points to memory address 100. And as we know that this is a array of integers, and let's say in my particular system the size of the integer is 4 bytes, okay. So if I want to access element at position 0, that is 0th index, so I know that this is 400. If I want access to array plus 1, that is the second element, right? So how exactly I can get that is 400, that is the base address, then plus size of element that we have in that array, which is equal to 404. Similarly, let's say I want to have access to second element. So what I can do, I have 400, which is the base address. Then basically this is the second element, right? So in the third element, so what I have to do, I have to do 4 plus 4. Or what I can do, size of the elements into the index, right? So what is the result? 400 plus 8, which is 408. Similarly, next element can be figured out, right? So it is 400 plus 4 size into the index is equal to, what is 4 into 3? 12, right? So 412. So this is how indexes work and calculation of random elements work. So this is the advantage here. Let's say I have to access a particular element. The general formula could be reduced like this. Element at position n could be ARR, that is the base address. Then we will add the size of that particular object. Right now we have integers, so it is 4, and let's say n. So this is how we calculate the position of a particular element. And as we can quickly perform this operation in mathematics, this is very easy to access that. If you compare these operations, this small calculation of the address of a particular element to a linked list. So this is very quick. So that is the advantage, and that is how it is being calculated. And why indexes are starting with 0? The answer to the question is within this calculation itself. Let's say instead of having index from 0, we started from 1, 2, or maybe let's say any of the customized values. So in that case, this calculation will become a little bit complex. So for that reason only, it is recommended, or most of the programming language follow this convention. But still, if we talk about a few modern languages or some primitive ones also, we have a few programming languages. We can customize the arrays also. Just like for an example, if you talk about Visual Basic or Basic. So in those programming languages, you can have any of the indexes as far as I remember. You can start your array from maybe index 10. That's not a foundation there. So does that answer your question, Palak?
Yes, sir. I asked actually this one.
I don't see the names actually.
No problem, sir. Thank you.
Okay. Okay, let's continue. So next we are going to talk about the disadvantages of arrays. So we talked that these are efficient data structures, right? But at the same time, these are having some disadvantages also. So first disadvantage is requires array size information during declaration. You see that when we declare a particular array, we have to define the size of the array. in our case, we took 10 as an example. Let's say I'm writing an application where I don't know how much element I may have. So in that case, it is difficult to deduce a value to declare that. And let's say for an example, I'm maintaining a record of students. So in that case, right now in my class, I know that it could be maximum 60 students. But let's say the same application can be used later by the university. So in that case, university may have thousands of students, right? So how can I manage that particular problem? So this is sometimes difficult, how exactly we have to manage this in terms of sizing information. So this is a disadvantage, because let's say right now I say that I have 60 students. It is feasible to have a 60 storage block, right? I can store information of 60 and I can simply declare an array with 60 size. But if we talk about thousands of students, due to hardware requirements also, because everything, whatever we do, right, it requires some space in memory while executing. So looking into those constraints, right, it is not feasible to have thousands or 10,000s or lakhs of memory blocks assigned to a particular application directly for a single operation, right? When a single application might be doing multiple operations or multiple similar operations, right? So in that case, we will run out of the memory or we will face some other issues. So this is the limitation. This is the limitation number one. Second is when we talk about C arrays, we don't have any bound check. Let's say, for an example, I have declared a variable array of size 10. But what if I'll try to access index 11 or maybe a of 10, that is the 11th index, right? Or some other random index, which is not in the range of 0 to 9. What happens? So those kind of checks we don't have in the C programming language, and we have to take care of those things, right? Similarly, let's say if you look into this particular block of representation, let's say this is a array element which contains only three values at index 0, 1, and 2. How can I fetch that data out of it? How can I track whether we have only three values within it or whether it has 5 values? Because the size I have defined is 10. How can I assure that I'm accessing a location which is having a valid value? Because it could be a possibility that I have declared a variable of size enough to carry my required size or my required number of elements, but I'm not using it fully. I'm using it partially for such a case. So this is the third disadvantage. So any question on these advantages from anyone? No? Let's proceed further then. So let's talk about how can we have access multiple elements out of an array. We talked about writing a specific index or fetching information out of a specific index. But how can we do this? Let's say I have multiple student records that I have to write or I have to fetch out of an array. How can I do that? Right? So the simplest way to do that is using the iterations or loops. I'll show you how exactly it is done. So what I'll do, I'll have a loop starting from 0 index to 9. And what I'll do, I'll simply allocate the values to that particular index. Let's say I into I, square of the index I'm storing, okay? So I'll try to execute it. Okay, it executes fine. So this is how we insert or write a value. But I want to fetch also so that I can validate whether it is working fine as expected or not. So what I can do, I can execute a loop again. And instead of fetching, instead of setting it, I'll fetch it. I'll print the elements while accessing them. Okay, I'll try to run this. And what I have done in this particular loop, I'm iterating across the array. And for every index, I'm initiating that index with the square of that index as a value. And in this array, I'm iterating across the array. And while iterating through those array elements, I'm printing them that this is the particular index value and we have this particular value here. So you can look here, value of 0 is 1, value of 1 is 1, value of 2 is 4, which is as expected, right? So this is how we write and read multiple elements out of an array. Right now for demo, I have taken it as an integer value, which is very simple, but it could be any type of data. It could be student, it could be a node of a linked list kind of a structure or something like that. It could be any complex data type also. Okay, any question in this? How to write multiple elements, how to read multiple elements? No? So far what we have seen, how to declare array, how to fetch elements out of an array from a random index, and how to write a particular element at a random index. But let's say we have to insert a new element, right? For an example, there are multiple operations that we can perform, right? Insertion, deletion, and search an element. And insertion could be, deletion could be at multiple positions, just like linked list. It could be at the beginning of the array, it could be at the last position of the array index, and it could be at a particular index, a specific index that I want to have a random value at. Okay, so we'll talk about the insertion first. And in insertion, there's the first scenario, which is the simplest of the insertions, is the last index or last position of the available array, right? So how exactly we can do that? We need to talk about that first. So if you look into the picture or the graphical representation on the slide, you'll see that we have an element of size 8 and it has 7 values already available in that, right? So how can I push another value at the last position of it, right? So the very first thing that we need is the length. If we are aware of the length of this particular element or the array, I can do that simply. I can simply use the array name, put that length as an index. Actually, we have to increment the index first and then we have to use that, right? So let's say there are 7 elements already, right? That is, 8th position can be referred to as 7th index, right? Because 7 plus 1 is 8, which is actually 8th element starting from the 0 index. So what I can simply do, I can put ARR of 8 equal to that element, whatever I have to push, right? So this is very simple. But the another challenge is we don't have information about the length here. So how exactly we can calculate the length of it? Any idea? Any suggestions around it? How can we manage the length?
Until the null character.
No, we don't have any null in array so far. We are talking about integers.
By increasing a count whenever we insert an element, so it will give the length.
Yeah, as we talked into the previous slides also, I said that there is a disadvantage that we don't have any track of the length of the array, right? So what we have to do whenever we insert a particular element into an array, we have to keep track of that. We have to maintain a counter variable, and using that we can calculate the length. If you talk about modern programming languages like Java or C#, in that case, we have arrays already available, and in those arrays we have a property named length, which is readily available, and internally the programming language takes care of it. The language maintains the size or length of that particular element or object list, right? But in case of C, we don't have that facility. So we have to maintain that ourselves. So as suggested by Amartya, what we have to do, whenever we input an element at a particular index, we keep a track of it. Okay. So similarly, as we are inserting the element, we can delete the elements also. This is also simple. How exactly we can do that is we can simply decrement the length or the counter variable. Let's say right now the index is pointing to the last position, which is the index 7, right? So what we can do, we can simply reduce the index from 7 to 6. That way, we are not going to consider last element which we wanted to remove while accessing the array next time. because whatever we are accessing right now is going to be based on the length or the counter variable. So we will simply point a counter to the previous element instead of that element, and that is deletion done. Next is insert or delete at the start. So we looked that insertion at the last position was one of the simplest operations. We simply pointed to a particular index and wrote a value. That's fine. But what we have to do right now is we have to insert a value at the starting of the array. So you can see from the picture clearly that we have 7 elements already. We have only one position left where we can put the element, but that position is at the end of the array, the last position of the array. So to insert a element at the first position or zero index, what we have to do, we have to first move all the elements to the next position of those. Let's say if we want to insert a particular array here. So first we have to move 7 to 8th position, 6 to 7 position, 5 to 6 position, 4 to 5, that way up until we have a position vacant at the 0th index, right? So that's what we are doing here in the second step. And once we have a vacant position, we simply use the array name, array index, and put the element here. That's what we have done. So is this process clear? How to insert at 0th position or first index? Oh, sorry, first position.
Yes, sir.
Okay, so similarly, let's talk about the deletion. How exactly we can delete it? What should be the step that we follow? Any one of you want to share that?
Same, sir.
Same means, can you explain a bit?
Like for deleting first element, we have to check whether the array is having any element or not, and we can simply delete.
Simply delete means, let's say from the starting position, that is index 0, I'm deleting, right? So what I can do, I can simply do ARR of 0 and something blank maybe. Is it? Or what else?
No. And we have to shift, I guess, other elements.
Yeah, the way we are shifting it for the insertion, similar to that, we have to shift the elements after deletion of the 0th element, because otherwise what will happen, let's say there are two challenges actually. Right now we are having an integer array, right? So I don't have any marking possible there, that I cannot mark a particular position or an index that there is no element. That is the first challenge, right? Because let's say for an example, we can think of putting it as 0 or maybe a minimum integer value for an example, but that is still a value, right? And we are still considering that while accessing the array elements, because this is the position 0, and whenever we fetch elements, we start from the index 0 by default as a practice. So that is the first challenge. And another challenge is whenever we are removing a particular element, right? So after that, we are wasting storage there. We are not going to use that in that case if we are not taking care of the shifting part of it, because we are saying that we are going to start from the index 0, but index 0 has nothing. The values start from index 1. So that is the another problem. So what we have to do, we have to simply shift, what we can do, we can simply shift all the elements one position towards the front of it or towards the index 0, and that will take care of it.
So one question.
Yeah.
You second point you have mentioned, like it will be a memory wastage.
Okay.
So anyways, we cannot use the memory that we have already allocated for our array because it's fixed in size.
Yeah, but if you are not shifting, in that case, the index 0 is not usable, right? It is still allocated to you, but you are not using it. Index 0 is something from where we start accessing elements by default, right? So what you will be practicing later on after deleting this way, that you will start from the index 1, because index 0 is something that you don't want to consider, right? That's why what we do from the position, we shift the elements so that at index 0, we have a valid value, and there onwards up to the second last element, we have all the valid values, and the last position is the one which is empty as before.
Yes, sir, but I actually didn't get this one properly,
Mhm.
because if we use the loop also, we have to iterate for all the elements,
Yeah.
last elements also.
Yes, when you iterate using a loop, you'll start from index 0, right?
Yes, sir.
But deletion means we don't have any valid value at a particular index, right? And
Yes,
right now the index that we're talking about is index 0. So
yes.
basically using the iteration, what you are trying to do is you are trying to access a position which is not having a valid value as per your business logic. You are doing something wrong in that case, isn't it?
I got your point, but my point is, when, like, suppose we have deleted this one, 8,
Okay.
which we have inserted, and after that we have used a for loop, okay?
Okay.
And as per logic, you have said it that we have to means shift it one element, and that last um, what it is, sir,
Last
column
index.
will be empty.
Okay.
And then when we want to display that one array elements, then
Hmm.
we will iterate, okay?
Hmm.
For iterating also, we have to give like 10 8 elements are there,
Hmm.
means array size is 8.
Okay.
So for you, while using for loop, we have to give I is equals to less than 8. So
Okay. Up to 7.
up to 7, less than 8, and there means we are iterating the 7th
Okay.
column also, na?
Okay, let me tell you in another way. Right now, you are iterating. Let's say we are considering that the array is not fully pushed into that, right? We have 8 elements, a space allocated for 8 elements, but we have, let's say, 4 elements only in that, right? So you can maintain using the counter variable or the length variable that we have 4 elements, right? But you are not maintaining from starting position, right? You have two things: starting position and ending position, where we have data, right? So end position you can maintain using the length or counter variable, but you don't know from where to start, right? Let's say we don't have 2 elements at the starting of it, so you have to start from the third index, third position, right? So but how exactly you're managing that in that case? You're not doing that. By default you're considering that your array starts from the position 0 or the index 0, right? So that is again a overhead. I'm not saying that this is not possible. If you look into the queue that we discussed last week, this is happening, right? We are maintaining rear as well as front variables just to mark the starting of a queue and the end of a queue. That we are already doing. So similar thing you can do here also. But in that case, this is not efficient. You are adding some overhead to it, the basic functionality of the structure. Getting it?
Okay, sir. Thank you, sir.
Okay, let's move to next. This is the insertion and deletion at a specific index. So if you look into the flow, it is very similar to the insertion or deletion from the 0th index. The only difference is we don't have to put that at 0, but it could be any random value. And whatever position you mentioned, that let's say I want to insert a particular element 5th position, right? Or 4th index. So in that case, what you have to do, you have to move all the elements there onwards, not from the starting, not up to the starting of the array or the 0th index. That's the only difference. Or in another words, you can say that insertion of a element at 0th index is a kind of sub test case of it. That if, let's say in this particular case, if we are providing the index 0 as an input, then this is that case. Those two are kind of same in that case. We don't have any differences. So let's say we are pushing a particular element at 4th index. What we have to do, we have to push the elements at 5, 6, 7 to the next available locations by one position, and then we have to insert at 4th position directly. Got it? So similarly for deletion also, in last test case, we talked about the deletion from the 0th position. Similarly here, what we have to do, we have to simply move all the elements next to that particular mentioned position or index that we have specified, one position prior to those existing positions. And then at the last position, we can simply mark the length correctly and it will take care of it. We don't have to worry about the data, what exactly we have at the last position in that case. Simply marking or taking care of the counter or length variable will do this stuff. So when we talk about array operations, we have a few more operations, and out of those operations, search is one thing which is kind of very common, right? So let's say I have a stack or a collection of DVDs as we took, right? So let's say I have 25 DVDs in my collection. I want to fetch a particular DVD, let's say a movie name XYZ. So how exactly I can do that? Simply, I can go through the collection. I can go through each and every DVD from the starting to end. And whenever I find that particular name of the movie, I can simply fetch that element. So similarly, what I can do, I can simply do similar operations on the arrays in programmatic word also. So when we search for a particular element, normally we use linear search, which is starting from the 0 index up to the last index. And if we get the element, we are good. If we don't find the element, in that case, the element may not be existing into that, right? And the other option that we use, or the other algorithm that we use, is binary search, which is kind of efficient if we talk about the search algorithm. But this is something that we're not going to discuss right now. We will discuss later as a part of algorithm searching and sorting. Okay. So this is just to give an idea that search is an option that we usually perform, and this is used to fetch a particular element out of the array available. Next topic is 2D arrays. So what exactly is a 2D array? Any idea?
It represents data in table form, sir.
Tabular format, you said, right?
Yes.
Okay, and why we need that?
That tabular form, row and column will be there. Matrix for matrix solution.
Okay, just to keep it simple, we can say it like this. We had variables, right, where we were storing a single value in a single variable. Then we had a problem that what if we have a huge number of variables, let's say 100, 10, or 1,000 variables. Sorry? Somebody was saying something. Okay, I'll continue. So we had variables. Then after variables, we get to know about arrays, which allows us to have an efficient approach towards storing multiple variables in a single slot or in a single collection. So what if we have a collection of a particular type and we want to have a collection of that collection itself? Let's say we are talking about arrays, right? So what if I want to have array of an array? How can I do that? So this is what we call as a 2D array. Arrays or list of arrays in C are multidimensional arrays, right? It could have multiple dimensions. Right now, whatever we saw till now is a single dimension. That is from left to right, we are seeing that array elements are growing in one direction. That's it, right? So let's say if we have two dimensions here, or we will put two arrays next to each other. In that case, we have two dimensions, right? First is from left to right, and second is from top bottom, right? So that is two-dimensional array. And why we need two-dimensional array? It has multiple reasons or multiple applications for which we can use it, as suggested by someone. Matrix operations, whatever matrices we studied in mathematics and physics also, we can apply those concepts. And let's say we want to specify some information in tabular format, just like Excel sheets, right? So in Excel sheets, every field is a particular, is in every, we store data in a particular cell, right? So if something similar we want to do, we can use these 2D arrays or two-dimensional arrays. And other usage could be to store multiple strings, right? So 2D arrays, how exactly we represent them? So it includes representation in terms of rows and columns. Every element of a 2D array can be represented using a particular row and a column number. If you look into the picture, so you can see that first of all, how to declare that, right? So the basic syntax is to define the type of the array. Let's say we have integers, so type is going to be integer. Array name could be any variable that we want to push, or we give it a name. And X and Y, we have two index values. So if you look into the just a second. If you look into the arrays, how we declare them, we had a return type, we had an array name, and then we had a size variable, which defines the range of the index. So in case of two-dimensional arrays, what we do, we simply add another dimension, just like this. So what it does, it can be read as ARR is an two-dimensional array with 10 rows and 2 columns to store integer variables. This is how we can read it. So the first index value or the first index size, it denotes the number of rows, and the second index, it denotes the number of columns. Okay. So if you look into this particular, let's say we have a integer array with size number of rows 3 and number of columns 4. So this is how we can represent it. So if you look into any of the cell, the number of row and the number of column represent that element. For an example, 0, 0, it represents the first row and first column. 0, 1, it represents the 0th row or the first row and then the first column. Similarly, other cells also can be pointed out. So this is how it is used in terms of representation and a human readable form. But how exactly it happens under the hood when we talk about the memory allocations? Is it going to be the same way, or is it going to be something different? That's what we are going to see next. We are not going into much details of the 2D arrays as of now, because this is something that we don't use very frequently, except a few utilizations we have in terms of solving problems. So this is how we can represent 2D arrays in memory. So if you look, you can clearly see that even 2D arrays are kind of contiguous memory allocation, similar to the one-dimensional array or a normal array. There is no representation just like this, which we saw in previous slide, that it is going to be in a tabular format. Because if we talk about the memory allocation, memory has a block, memory has different storage location blocks assigned next to each other, right? And we don't have a facility to point it like this in a tabular format as such. So what we do while doing the allocation, we have two approaches. One is row measure and another is column measure. So if you look into the first picture, it is row measure. What we are doing, we are accessing all the elements of the first row first, we are allocating them. Once that is done, we are going to access or store second row, then the third row elements. And if you look into the right side of picture, that is column measure. We will give priority to the columns, and based on the columns, we are storing the information. First column first, second column then. Then after that, we have third column, and then fourth column we have in that. That's what we are doing. How to initialize 2D arrays. So there are multiple ways to initialize 2D arrays or two-dimensional arrays. The simplest assignment or the most widely used way is the first one. That is, let's say we have integer array of size 3 rows and 4 columns. So what we do within the braces, let me explain it here. So what normally we do whenever we have an integer array of single dimension. So how we can do that initialization is something similar to, let me clean it. Something similar to we can do. We can use braces, and within braces, what we can do, we can put comma separated list. Okay. This is how we can do that. So right now we have two-dimensional arrays. So what we can do, we can simply use the similar syntax. We said that it is arrays of arrays, right? So what we can do, we can simply put another dimension here for an example. Let's say 2 columns. So this is first column we have already. We will separate it with comma and put another column. Just a second. Just like this. And the whole thing is going to be in another block. So this is how it works. So if you look into this and we put it this way, it is similar, right? We have 2 rows. Sorry, we have to get 5 rows and 2 columns, right? This is what we have to do. Right now, this is 5 rows. So we can put more comma separated blocks and put elements there. And the problem, sorry, I made a mistake. We have 2 columns, right? So this should be like this. Okay. It could be something like this. So we can add 2 more columns. So for readability, what we can do, we can push them into multiple lines. So this way you can see we have 5 rows with 2 columns each. So this is what we do to initialize the 2-dimensional array. Okay. Or the other position, other way of initializing it to have a continuous allocation, that is the second way. In this, we don't have to manage multiple blocks or multiple arrays. The compiler will take care of that part. So the way we have 2-dimensional arrays here, we can have multi-dimensional. We can have 3, 4, 5, so many. But practical usage, if we talk about, then we don't have much usage over 3-dimensional arrays. I have seen only 2-dimensional arrays only while working, but I never used even 3. But in some cases, I have gone through that it is a possibility of having 3-dimensional arrays also, but we never used it. So if we talk about how can we access elements of a 2-dimensional array, so this is how we do. The first line, integer a52, it declares a 2-dimensional array of 5 rows and 2 columns, initialize that with some elements as I demoed. And then next we have integer I and j. These are kind of counter variables or index variables, we can say, which we are going to use, right? So how exactly we access the elements, I'll show you using the memory representation here. You can see that we have 2 loops going on. For I equal to 0 to 5, which is going to represent row, and the second one is from j is equal to 0 to j smaller than 2, which is column. So what we are going to do, we are going to access a particular row first, all the elements of a particular row first, and then elements of the second row, and then the elements of third, like that. So we are proceeding this way. First, we will have access to A00, then A01, A02, A03. First row is done. Then we will move to next row, that is A10, A11, A12, A13. I can show you how exactly it works. I have already written that program here just for demo purpose. I'll simply run it. So this is how we did that, right? We have 2 columns of information stored in 5 rows, 0, 1, 2, 3, 4, and 0, 2, 4, 5, 6, 8. So what we have done, we have simply initiated a 2-dimensional array with values, and we are executing a particular row. We are executing a particular loop, which takes care of the rows. It points to a particular row and it points to a particular column at a time. So what we are doing for each row, we are trying to access each column first, and then we move to next row and all the elements of that column. That's what we are doing. So if you look into this, A of I and j, line number 14, you'll see that this is the row and this is the column, which is being denoted by j and I, these 2 variables. So we'll move to next thing after initialization of it and accessing elements. Do we have any questions so far on 2-dimensional arrays?
There is one question in the chat, Vikas.
Yeah.
How would we know that an array is row major or column major?
That is specific to the compilation implementation. Actually, that is not something we should be interested in as a programmer. We should not be worried about it. It is something that compilation and the execution environment takes care of it. Means, is there any specific reason for asking that question? Means, if it is impacting somewhere your application, then we can think of it. Otherwise, I don't think that we should get into that as such. Anything? Anything else?
No, just this one question.
Okay. So next topic is C strings. We were talking about two-dimensional arrays of integers so far. So, sorry. Next is C strings. In C, strings can be represented as an array. That's what we know. I know that few of us already know about it. But so a string is a sequence of characters terminated with a null character. That is the definition. And if you look into the representation also, what we are trying to do, first we are trying to define an array and initialize that array with characters, right? We have a character array and that is initialized with the string C string itself. When we talk of a string, we mean a word, a sentence, or any language specific or any English type of content. That's what we are talking about. Okay, which is comprised of all the numeric values, or I'll say alphanumeric values. Okay, so how exactly we represent C strings in C? So the memory allocation and memory representation could be like the blocks given below on the slide, that we have allocation similar to the integer arrays, but instead of integers, what we have in that is we have characters stored within that array. And the additional thing that we have to make a note of it, that every string is going to be null terminated. That is, whenever we initialize a particular string or an array of characters, and we want to treat that particular array as a C string, what we have to do, we have to assure that we have a null character at the end of it. It has to be null terminated. So the way we are initializing it right now, that is character C, then brackets equal to C string. So what exactly the compiler is going to do is, compiler is going to allocate a memory based on the provided input, that is C string, equal to the length of that plus 1, and it will also put the null character at the end of it. We don't have to worry about the initialization part using termination character in this case when we are doing this kind of initialization. There are few other ways to initialize character arrays, and these are given on the screen. The first one is simply C is a character of C is an array of characters, and we are initializing it with ABCD, and compiler will put the null termination character also by its own. Similar to that, the second one, but in second one, if you see that we have defined the size is 50, but we are initializing with ABCD, right? So in this case, any idea what will be the size of the string? When you try to access a string, what exactly you're going to get? You are going to get 50 characters or 4 characters?
4 characters.
Why 4 characters in that case?
Because if initialization is A, B, C, D, so a character occupies 1 byte in the memory.
But the size is 50, right? I have allocated memory for 50 characters.
Okay.
So how it is going to know that this is ABCD only and this is not ABCD and some other characters up to 50?
50 is the maximum size of the character array.
Yeah, but while initializing, I'm putting only 4 characters.
Yes. So it is 4 bytes only. The
So let's say
next will be, I think it will be blank.
Let's see.
All the after that.
Okay, let's quickly see that. Okay, so what we are doing there is character CH 50 equal to ABCD, right? This is what we have done, right? So let's try to print it. I'll try to print it using percentage formatter because this is a string, right?
Right.
Close braces. Okay, so it is printing ABCD, only 4 characters, but the length is 50. How did it identify whether this is 4 only?
Actually,
Dash
this is
0 will be last character, sir.
Okay. So if null is the last character, how exactly it identified that based on that or something else? Because if you look into the, I'll go to the slide again. So basically, if you look into the first statement and the second statement, both look similar, except that there is a difference in the size, right? That we have specified while declaring it,
yes.
right? So means, are they different or are they same?
Different, sir.
Different, sir.
Okay, what is the advantage of the first one or the second one over other?
First one will allocate memory only for 5 characters and second one for 50.
Okay, but what is the advantage there, right? In both the cases, I'm storing only 4 characters. So why exactly I'm doing that 50?
50, you can store maximum 50 characters. But in the first one, we are limited only with ABCD only. We can't insert any more character in this.
Okay, so
Second case, we can maximum 50 last.
okay, so let's say, means what I got out of the conversation is that if I want to initialize it, the ch variable with something else, maybe a longer string, in that case I can do that. Is it?
Yes, you can in
Means
like
I can
any
try to
longer
put more
string. Yes.
characters.
Okay.
Okay, let's try that too. So normally, as we do with other variables, I will try to do this also. You mean something similar, right? Or let me know if you want to change something. Not this. Let's say something random. So this should work according to you. That's what you're saying, right?
No, sir, this won't work.
Okay, why this will not work? Do you know the reason?
Because we are not at the starting you have told us, sir, collection we have to use.
So CH is a collection, right? We have already declared that.
But we are not using that bracket now.
Okay, so you want me to initialize it in a different way. That's what, right? You want me to initialize like this, right?
No.
Then this is how we initialize, right?
Yeah, sir. But we initialize this way only a single character, not the string.
Yeah, but every element is a single character of array, right? If you look
Yes.
at the line number 6, we are defining that CH is an array of 50 elements of type character, right? So that means I can store 50 characters. So 7th line says that I am trying to put 0 index with A, first index with B, and so on. Isn't it?
Yes.
So how can I be wrong in that case?
Sir, I'm not that much good in string. I cannot answer.
Okay, no problem. So if you look into that part, let's talk about the other two initializations first, and then we will come back to it. Okay, so the third one is character C equal to ABCD0, whatever I was trying to show you now, right? So in this case, in the case third and fourth, if you notice, what we are doing, we are trying to put the null characters manually, right? Do you see the difference in the first, second, and the third, fourth initialization patterns?
Yes, sir.
Okay, so why is that? This is because when we do the first way and the second way, we are providing the complete string and compiler is responsible for the initialization of that string, right? Compiler is taking care of the taking care of the termination character as well in that case. But when we look into the character third and fourth, so in that case, what we are doing, we are initializing element by element. And when we are doing so, we are liable to do the termination part of it. We have to take care of that part. Okay. And if you go by the second line, right, in that case, once you are done with that, you cannot, you are not actually allowed to change the string, right? Even if we have defined a character array of 50 size, and I have stored 4 characters only in that, right? So I cannot directly initialize with it, initialize that particular character array into some other values. It can be initialized in this way only at the time of declaration. Once declared and initialized in this way, we cannot change the values directly, similar to this.
One doubt, sir.
Yeah.
It is like in Python also we are having like strings are mutable, we cannot change. So same way you are telling, na?
See, mutable and immutable is a different concept. Here we can change, but this is not the way we can change. We cannot simply assign the values, just like if we talk about integers, right? In integers, what we do, integer a is equal to 2, and in the next statement, what I can do, a is equal to 5. I can simply reassign the values, right? But in case of character arrays, we cannot do that simply. That is a limit, that is a implementation from the C side itself, that we are not allowed to do that. Okay.
Oh, thank you, sir.
One question.
Yeah.
You mean to say that once the string is initialized, it cannot be changed, whatever be the size as the time of initialization?
Look into the current slide, you'll get the answer.
Okay.
Okay, so basically this slide says that C strings do not support the assignment operator once it is declared as shown, right? And what we are trying to do is we are declaring a character of 100 characters. We are declaring a array of 100 characters, and then we are trying to initialize it in a next line. But if I'll modify it a bit and I'll initialize it at the time of declaration, there will be no error. Okay. I can show you that. That will make it clear. So this is what we have already seen, that we try to initialize and it works fine, right? I have to, sorry, what I have to do is I have to do this, right? This is what we are trying to do there. So in this case, if you'll see that there is a error itself, right? Expression must be a modifiable value, and when we try to run it, I get one error generated here. And the error is array type character 50 is not assignable. This is what we were talking about. Okay.
Okay, sir.
So this is something which compiler enforces. This is not something that we can do. So next topic is functions in C. Before that, any questions around arrays or strings in C?
So it is not question, but just like that I wanted to ask. For printing a line with spaces, we means when we wanted to take that a statement from a user, we cannot simply use %s, because as soon as it gets a white space, it cannot continue and it stops taking the string.
Correct.
And while printing we can use. Why, sir?
That is specific to the implementation, right? So white spaces are something which could be a tab, which could be a space, which could be a new line character and all that, right? So if you look into the definition of the get s function, so get s function is designed to take only word, a single word, right? So for that we have some alternatives, right? Actually get s works based on some regular expression filtrations, right? Or the format specifiers that we use can be used, means the format specifier can be used to control the kind of element we have to get as an input. Those things we can do. So you might have seen in our previous assignments itself, right? The linked list one, or maybe the postfix expression evaluation, right? In those cases, what we are doing, or maybe in the last assignment for this session itself, the fundamentals of C language, you might have gone through, right? So there were 3 types of inputs we asked you to get. First is the character, second is the word, and the third is the whole statement. right? So what we did there, we use an alternative approach because getS is a library function which is already defined to behave in a certain way. We cannot control that, but we have some alternative options to do that. That's what we did. We used scanf with %s and a regular expression in that, right?
Yes, sir.
Yeah, so we have alternatives to do something, but if something is already available and that particular thing is written in a certain way for some historical reasons, we cannot change that.
Okay, sir. Thank you, sir.
Okay. So let's start with the functions in C. The simplest definition of a function is a collection of statements that execute sequentially to perform a task. Okay, and so far we have already used multiple times a function named main, right? So if you look into the function, let me go to that. So if you look into this function, whatever we have been using for some time in today's session, so this is a main function which is already defined, right? And as the statement says, a collection of statements that execute sequentially to perform a task. So what exactly is happening? We are executing these statements in sequential order. First, we are declaring a variable, we are initializing or trying to initialize a variable, then we print that information and print a new line character. So these are the 4 instructions basically that we are trying to execute in sequential order. And this is happening within a block of code, which is defined by these braces, opening brace and the closing braces. So this is a function according to definition. Fine. So any block of code which is given a name, a logical name, and performs a specific task is known as a function in C. Okay. We have 2 types of functions. First one is library function and second is user defined or custom functions. When we talk about library functions, we just discussed the function getS, right? Which is readily available as a part of C programming construct itself within the C programming libraries, and we have not defined it. We are just using it. Similarly, we are using scanf and printf functions, right? So those things are already readily available and we don't know how exactly those are implemented, but still we are using it. So these functions are known as library functions. And the other type is custom functions or user defined functions, which are to be defined by a particular user. For example, we define various functions in our assignments also, right? In last assignments or in previous assignments, you might have written a function to calculate or evaluate postfix expressions, right? So that definition is something that you wrote. The business logic within that block of code was something that you have decided that this is something we should do. So those kind of functions which are decided and defined by a user are known as user defined or custom functions. Okay, why we need functions? So there are various reasons that we can go through why we need a function. First reason which comes to or which allows us to go towards the functions or usage of functions is code redundancy. What is code redundancy? Any idea? Can anyone tell me what is code redundancy?
Yeah, so the code can be used again without writing it again. It's the code can, if you have to use some thing again in a program, then we don't need to write it again and again. We can use it by defining it in a function and just call it.
That is not code redundancy. That is code duplicacy or reusability, better I'll say, right? Redundancy means duplicacy, but you are talking about reusability. Those are different. Okay, so as the word redundancy means duplicacy, we can see that code duplicacy is one of the reasons that we should go with the functions. Why? Let me explain that with an example. Okay, let's say I have this character array already or a string already defined, and I want to use this ch variable and display it. So what I'm doing, I'm using printf to display it. Let's say I have to display it multiple times, right? So what I'm doing here, I'm simply duplicating the code, right? When I try to execute it, what happens? Oh, just a second.
So just remove that ch character 6.
Yeah, so it is printing it multiple times, right? You can see here. I have not placed any new line character. That's why it is coming into the same line. So basically what we have done, we have duplicated the code here, right? I wanted to print something multiple times. So for that, I have repeated the same statement multiple times. This is what I have done as a general practice, right? And right now, the example we are looking into is simple. We are simply printing a particular string on the screen. That's it. But in general, there could be a need or there could be a business logic which needs to be executed multiple times, right? Let's say I want to get a user input again and again, right? So in that case, what I will do, either I can write it this way. I can ask for the user input again and again with the same set of statements similar to this. Or maybe let's say we have some complex operation that we have to perform. Let's say we have to print a document. Okay, so printing a document is something which takes thousands of lines of code, right? So I cannot repeat the 1,000 lines of code again and again. So what I'll do, I'll prefer to push that particular information into a logical block and name that block. Okay, so that will become a function. And I can simply call that particular function again and again whenever I need to print a document. Instead of using those 1,000 of lines, let's say I have to print 10 documents. So 1,000 into 10. That's what I have to write otherwise, right? And in that case, the another issue is I can make mistakes. So to remove that problem, to get a solution to that particular problem of code redundancy, we use functions. What I can do, I can simply put that business logic of 10 lines or 100 lines or 1,000 lines into a block of code, name it with a function name, and I can simply call that. Next reason to have functions is better maintainability. As I said, let's say I have a business logic of 1,000 lines. Okay. Whenever I want to change something, I can simply go to that particular position and change, and it will impact all the calls. Wherever I'm calling that particular function or I'm using that particular method, it will reflect everywhere without any mistake. It will be the consistent behavior across the application. Okay, for an example, I'm writing a simple method. Okay. Int calculate. I am passing two variables of type integers. Oh. And what I'm doing here is returning, or instead of returning, let's say print for now. Okay, let's call this function and see what happens. Okay, so if you see, the result is 9. Let me push a new line here for clarity. Okay, so it prints result equal to 9. And what exactly I have tried to do is I have simply written a small logic to add two numbers. Okay, so let's say I'm calling this particular method multiple times into multiple locations. Okay, with different parameters or values. Okay, it works fine. But let's say in the future the requirements changes, or maybe I got to know that the logic written within the calculate is wrong. I should not have done addition here. Instead, I need a multiplication. Okay, so in that case, if I am repeating the code, okay, as a usual practice, whatever we used to do without functions, so in that case, I have to change this particular logic in each and every place. And let's say if I'm not able to change that, or if I miss it, I miss a particular place where I have to change it, but I didn't change it. So the whole output of the business output of this particular code is going to be wrong, right? So functions allow better maintainability in terms of this. I have simply changed it at one place, and whenever I'll execute this, it will reflect and work consistently across all the calls. This is another problem that functions resolve. Okay. The third concept around it is modular code. It breaks a functionality into multiple small ones to enhance readability and reusability. This is something that we have already experienced so far in the assignments. Let's say in the linked list, we have a function traverse, right? What exactly the traverse function does is it performs a basic operation to go through each node of that particular linked list and print the element or identify a particular element to do some other operation on that. So that is a specific objective that traverse function does. Similarly, we have a print linked list function in linked list that we have created. So what it does, it goes through each node and prints the information within all the nodes of that linked list. So that is again pushing a specific objective or a result after performing some operations. So in that case, what we learned out of it is that instead of creating a particular function, let's say main, every application that we create in C is starting with the function main. So it is not a good approach to write thousands of lines or lakhs of lines within the main function. It will work, right? That is not a problem that it will not work. It will work, but the code will become very complex to understand. It will not be readable. But if we break that particular problem into small chunks, right? Let's say we have differentiated the stuff based on the intention. For an example, traverse, for example, print list. So the name itself says print list, right? So it is going to print a particular list. So that way the code is readable as well as reusable. Let's say I've created a function print list. I can use that to print list for any kind of list maybe, or any of the linked list. So that enhances reusability as well as the readability. And the fourth reason is abstraction. We use get as function, we use scanf function, as we already talked about. Those functions are something that we simply use. We don't even want to know how exactly these are working or these are written, right? We don't want to understand how exactly the code is working within that function. So this is the beauty of functions, that we can use a lot of stuff, simply reuse and get our stuff done without even knowing what exactly is happening under the hood. So these are the requirements or the problems that functions or using functions resolves. Okay. Any question on this? Nothing? Okay. How a function works. Let's look into that. So a program will be executing a statement, executing statements sequentially normally, right? And inside one function, when it encounters a function call, what it does, the CPU puts a kind of bookmark at the current position of execution and then calls or executes the function named in the function call. And when the call function ends, the CPU returns back to the point it bookmarked and resumes execution. So for an example, if you want to relate it to a daily routine example, what you can relate it to is, let's say you are reading a book. You are on page number 8 at a particular line. Okay, let's say page number 8, line number 10. And you just remember that you have to make a call to a friend, which is urgent. So what you will do, you will put a bookmark on that particular page number 8, and you'll put a bookmark that page number 810. This is what you have already done, and you have to start there onwards. You'll put a bookmark and you'll make a call to your friend, you'll finish the call. And once the call is done, what you will do, you will come back, you'll open the book from the same bookmark position, which is precisely the same position that you left at. And then there onwards, you will start reading. So this is the exactly same thing happens when we call a particular function in an application. Okay, so if you look into this particular thing with the help of an example, I'll show you. So what exactly we are doing here is we are starting our application with main function as usual. what we are doing, we are encountering this calculate function. So whatever we have done so far is done. When we reach line number 11, we move to this line where the definition of calculate function starts, line number 4, and whatever is given within this definition, we execute that. And as soon as we get that this function is complete at line number 6, we again come back to line number 11 and start executing next operation, which is line number 12. Again, the same call. And similarly, when 12 line executes, we will go back to 4 number line. We will execute 4 to 6. And once 6 is done, we will come back to 12 and next line will be executed, which is line number 13 and so on. Okay. Any question on this related to the flow of a function, how exactly it executes, or how is it managed? So we have seen that what are the advantages of a function or what kind of problems a function resolves, right? So after that, let's talk about creating functions. How can we create a function? So when we talk about creating a function, the basic syntax that we use is as displayed on the screen. It has a return type, which defines what kind of data it is expected to return, because there could be a possibility that we have to return a value. For an example, we are getting input from a user. So if we're getting a input from a user, we may want to return what exactly the input is to a calling function, the parent function, right? So this is what it defines. Next is the identifier, which is the name of the function. And then within the parentheses, right, we may have some parameters, that is the values that it may need to perform an operation, and we may have to pass. And it could be nothing also. So right now for this particular syntax, it is nothing, but we may have any type of variable that we may be interested in dealing with as a parameter or as a value to be passed. And then within the brackets, we have function body, the business logic, how to perform and what to perform that particular data, whatever we have received as a parameter or whatever the business logic or the function is intended to do. Let's say for an example, in our case, we took an example of calculating sum of two numbers. So that is a function which performs sum. So when we look into this particular thing, we come across another concept, declaration of a function and definition of a function. So let's talk about that with an example. So if you look into this block, line number 4 to 6, whatever we see here is declaration plus definition of a function together. It says that we have a calculate function, or we have a function named calculate, which takes two integer values of type, which takes two values of type integers and returns a value which is of void type, that is nothing. Okay. And this is the definition of the body. So collectively, we can call this as a definition of a function. Okay. But sometimes there is a need that we don't want to define what exactly the function is going to do, but we want to define that we need a function of this type, or which is expected to do something similar to this, or maybe this is the structure of a function, but we don't know how to do that, particular logic. So in that case, we use declarations. What are declarations? If you look into this particular line and I change it a bit, instead of providing a body, if I simply put a semicolon at the end of it. So this is known as declaration. Declaration is basically something which tells the compiler about a function's name, return type, and a parameter. What kind of parameters it accepts, what kind of return type the function has. And it will make the compiler happy for the compilation part of it. And this function's definition could be in separate file also. If you look into this particular file, the sample application, we have a small program, right? We have a main function and we have a calculate function. So we have declared and defined all those things within the same file. But usually we have larger applications, and in those cases, we may have multiple files spread across multiple directories also. So in that case, if we want to specify that we have a function like this, but we don't know the definition in the same file, We may have the definition defined in another file. So this is what keeps compiler informed about the function, that this is the declaration of the function which is written somewhere else in some other file, and we are assuming that this will be available during the execution also. Okay, so in that case, compiler will not throw any exceptions or not exceptions, any errors while compiling the code, because compiler knows that this is function which is available somewhere else, and it will be taken care of. These are a few examples of the functions declaration. So first one, if you look, this is a function that takes 2 integers as parameters and return an integer. Okay, then the second one is a function that takes a integer pointer and an integer variable as parameter and returns a pointer type of integer. Okay, third one is function that takes a character parameter and returns a reference variable or a pointer variable. Okay, and the fourth one is simple fun function which takes a character and integer input and returns an integer. Any questions so far related to functions?
Yes, I want to ask, can we call a function inside a function, same function?
Same function within that definition, that's what you are talking about. Yeah, we can do that. There is a concept, we call it as recursion. So recursion is the process of calling same function, or means a function calling itself actually, which we are going to discuss later, not right now, because that is something which needs some other kind of knowledge also.
Okay.
Yeah. That is possible, but the thing that we have to keep in mind is that it is going to be in an infinite loop in that case, right? So we should have a termination condition so that we don't run into an infinite loop of calling itself again and again. Otherwise, it will crash the application.
Okay.
Okay.
And can you explain some example of this third type? Character as parameter and returns a reference variable.
Okay, it is simply returning a character pointer, nothing else.
Character point. Okay.
So if you look into the character arrays, right? So character arrays are something which can be represented through pointers, character pointers. So we cannot we cannot return an array directly in C, a character array in C, right? That is not possible. So what we do, in case we have to return a character array, what we do, we return a pointer to the first position of it.
Okay.
Yeah.
Okay, fine.
Okay, next is how to call a function. So basically we know how to define and declare a function. Next is how to call a function. So while calling a function, we need to pass the required parameters along with the function name. Let's say I have a method sum, which takes 2 integer variables, right? So while calling function, I have to provide 2 integer values to that. That is the first thing. Then if the function has a return value, it is optional to store that value, whatever is returned, or we can simply discard it also. For an example, I'll go to the example that we have written. Let's say instead of void, I'm doing int. And instead of printing it here, the function definition is returning us a plus b. Okay, so in this case, we are expected to get an integer value as a return value, right? So let's try to run it. We will not get anything on screen actually. One error generated.
So there you have declared the function as void.
I have changed it. Okay, there are 2 lines. Okay. Okay, so we are not going to have any input as such because I'm not doing any print statements, but what I can do, I can print the result here. So let's say I'm calling it with 4, 5, and I'm collecting the return value into X. what I can do, I can print X now to assure that we are getting it. See, it says result equal to 9. Okay, so this is optional actually. If you look into this line number 13, this part is optional. I can collect the value, whatever is being returned, and I can simply discard as I'm doing in line number 15 and 16 also. Okay, so this is something which we have as an optional. Okay, third one is formal parameters and arguments, actual parameters of a function. So when we talk about a function and when we discuss within the team about a function, we usually come across this this word formal parameter as well as arguments or actual parameters. So what exactly these are? So if we look into the declaration definition of a function, so this is the definition of a function that we have started with, right? So the variable a and the variable b, these two variables are known as formal parameters. Okay, so basically when we talk about a formal parameter, the scope of a formal parameter is within the function or within the block. Whenever we start executing this particular function at line number 3, we will have integer a and integer b in existence. And as soon as we return from the function, or as soon as we close executing this function, we will not have these two variables available anymore. Okay, so these are known as formal parameters. And wherever we call, we pass some values. Let's say we are passing 4 or 5 here. So these are known as actual parameters, whatever we are passing to that particular function. So this is just a concept which is being used in discussions within the teams sometimes. So it's good to have that. Nothing special about it otherwise. Okay, when we talk about return values, many functions we see have void as return type, right? So let's go to this function again. We made it void initially, right? And let's say we have a lot of code in this, and I want to return based on some condition. For an example, let's say this is not returning anything, and we have a lot of code written it. How can I break that? There could be a possibility that I don't want to execute the complete business logic of function and I want to return and I want to terminate a particular function. How can I do that? That can be done with the help of a return statement, simply this. Return like this. What this is going to do is this is simply going to return the control of this function to the caller, the parent function. It will simply terminate without doing anything further. You can consider it similar to the continue or not continue, break statement of a loop. Whenever we want to break a loop or iterative construct, we put break. So it comes out of that loop. So similarly, if we don't have if we don't want to perform anything and we simply want to return out of it, what we do, we simply return out of a function. Okay. This is applicable when we have a void data type as a return value or return type. Okay, why we need return types? This is what we have already considered actually. So still any questions anybody is having?
Vikas, can you tell more about why when we need declaration of a function?
Declaration is basically just to notify a compiler that this particular function is available somewhere in some other file and not in this file. So for an example, if you have written a
Packages.
Not packages, I'll show you. So if you look into this function, this program, whatever we have written, right? We have done stdio.h as an inclusion, right? So we are using printf function here, correct? Normally, if we want to use a particular function, we should be aware of the definition of that function, right? Just like we have calculate function, which is written by us, a user defined function, right? So before calling, we're defining this calculate function here, right? So in case of library functions or in case of complex applications, what usually happens, we don't have a single file, right? We have multiple files involved. So in those cases, just to notify the compiler that we have this particular function available somewhere else, we use the declaration that this is the declaration, this is the signature of a function, which includes the name of the function, the parameter types, and the return values, that this is something which is already available in some other file, but not in this file. So while compiling this file, please ignore this part. If you find that this is not available, means just ignore and skip, and it is available already, we assure that. This is just a kind of notification to compiler. For example, I have two files, file 1 and file 2. In file 1, I simply give that declaration of calculate function, right? But the definition is in file 2. So how can I make that notification that this is the declaration, this is the definition, right? So declaration says that this is a function which is available in file 2. So while compiling file 2, you'll get that, I assure you. But please, when you compile file 1, don't mark it as an error. That is the notification.
Because in this function, if we write the calculate function after the main function, then it will show error or not?
That is a possible case of declaration requirement actually, because as I said, whenever we compile a file, a source file, in that case, it executes sequentially, right? So it will encounter main function first, and within the main function, it is trying to calculate, and definition of calculate is not available as such, right? So what we will do, we will have to either define this function before the main, as we usually do most of the time. If you may have observed, most of the time main function is the last function in a file for that reason. Or the second thing that we can do is we can simply declare it once to notify that this function is available. This is available somewhere, and this is not going to throw an error in that case. Just a second, void calculate.
Sir, that return type is void in, I guess.
It is same, I copied it. Okay, calling. I'm calling it here. Because of this, I'm getting that. Okay. I'm trying to print that, right? And I have commented it already. Okay, so now it has worked. So basically what I have done, if the function definition is after the main function or the function where we are trying to call that, in that case, we use declarations. It is similar to other file, right? It is not able to find that function definition in sequential flow. That's why it throw error. But when we notified that this is available somewhere, it didn't throw any error.
Yes, Vikas.
Okay, and the fun fact is function can be written once and can be called multiple times, just like we have already seen. Okay. So function call types. When we call a particular function, we have two types of calls. Function can be called by value or function can be called by reference, right? So what is the difference between call by value and call by reference? So a quick example we have already seen while discussing pointers earlier, but we can talk about it today itself. So if you look into the calculate function that we have used. So I'll modify it a bit. I'm not changing the function name. I'm simply changing the logic of it to return, not return actually, to change A. I'm trying to increment the value of A. That's what I'm trying to do, nothing else. Okay. So calculate is being called with value 4 and 5. Instead of this, I'll put it in a variable for it. Well, integer. And then I'll use A. Okay, I'll comment this one. So what I'm trying to do is I have a variable A, which is initialized with value 3. I'm calling a function calculate and passing that value A. So I am doing incrementation on the past value, and my expectation is that whenever I call this function, I get this particular variable incremented. right? So let's see if it works that way or not. When I execute it, what I find written data may. Okay, it is a warning. I thought it's error. Okay.
So it is printing result equals to 3.
Yeah, I want to print it twice, just before the call as well as just after the call, so that we can see the difference. Okay. So if you see the output after the call, it is 3, and as well as before the call, it is 3. It is not incremented actually, which was not the expected result, right? So this is call by reference. What exactly is happening whenever we are passing a particular variable a here? The value of variable a is getting copied into this a, and whatever we do in this a within this function is applicable or is residing only within this function definition. Once this function vanishes or terminates, we don't have any results getting affected to the original value. So this is call by value. So what is call by reference? Call by reference is, let's say I want to change the value as expected, right? So in that case, instead of passing a, what I'll do, I'll pass the pointer or the reference of it. And I'll change it here also, integer asterisk. That is pointed to a. And I'll change it like this. So basically, when we use reference, what we are doing, instead of passing the value of a, we are passing the address of a. And we are receiving the address of a here and then performing operation using that pointer. That is the original variable. So in this case, I expect it to return with the, what happened? One conflicting types of calculate integer. Harsh, can you help here? I have not used references for so long.
Yeah, it's because of the declaration. In the declaration, it is int. So
Okay. Okay. Pointer. Two warnings generated. Okay. In the results, if you see, it is 3 still. What is the mistake that I've done? Address of a I'm passing, and within the calculate function, this is right? Or am I making any mistakes? I don't see anything wrong here. Value at a plus.
I guess we have to return the value of a.
No, returning is a different concept. I just want to modify the actual variable. Returning that we can do.
So first time it will return 3 because it is a plus plus.
So please try with in pre-increment operator.
That should not make any difference because once this is changed, this is changed. Okay, just a second. Let me do this way. A is equal to, even if it doesn't work, that's not a problem. Yeah, now it is functioning well. So before the call, it is 3, and after the call, it is 4. So basically what we have done, we have, instead of passing the value, we have passed the address of the variable itself. And we are operating on the original variable within the function. So this is call by reference. Okay. So these are the two types of calls that we talk about function calling. And how command line arguments works in C. We are running out of time. This is the last thing we'll talk about, and after that we'll not talk about anything new. So how command line arguments works in C, right? So if you look into this particular thing, okay, so I'll show you. So if you look into this method, right? So ls is executable and I'm passing some arguments, right? Minus al to it. And based on the arguments, this particular ls application is doing listing of listing of files with these two into consideration, right? So how exactly we pass these parameters to an application using command line? This is what I want to look into it, okay? So I've already written a main method for that. And when we talk about arguments, right? Command line arguments. So what exactly is happening? We are calling a executable with some parameters known as command line parameters. And these can be taken care with the help of these two type of arguments. So if you look into the main function, which is being called by any of the operating system methods or any other application, right? So this function is defined such that it accepts multiple arguments, right? Or the command line arguments, or I can say the user input while calling itself. So we can see that we have two parameters. The first one, argc, argc, this defines the number of arguments that we have received while calling the application. And the another one is, it is a pointer to the strings. It's a string array, right? So what it contains the arguments actually which this particular number denotes. Let's say I say that I pass 3 arguments. So the 3 strings are stored within this, and this is updated to 3, that there are 3 arguments. How exactly it works? We simply use it as a counter variable to loop through, and all the variables, whatever we receive as arguments, are stored within this, right? So using that index value, I can simply access those strings as I am doing here with the help of %s formatter and argument I. Okay, so how exactly it works, I'll quickly show you. I'll compile it and I'll run it on command line because it takes care of the parameters, right? So if you list it, you'll see that main method is the application name, right? So I'll execute main method with, let's say, I want to pass Vikas is trying something. Okay, so you'll see that I have got that within the application. So whatever I have given as arguments here is available here, right? So this is how command line arguments work. Right now, I'm simply printing all the arguments that I've got. Based on these, you can perform various operations also, right? So this is what I wanted to talk today, and we are short on time, so I don't want to start on another topic. So any questions so far related to today's session topics or previous topics? We can talk about them quickly.
Sir, in last one assignment was there playing with characters. In that, I have tried with that scanf function. When I code, sir.
Sorry, I missed your communication in between.
I wanted to show my code and then ask.
Okay, sure. You can share your screen in that case. I'll stop sharing. Harsh, can you please make her presenter or host?
Yeah, she can share, and but you need to unshare screen first.
Yeah, I've stopped. Yeah, please go ahead, share your screen. Meanwhile, if anybody else wants to ask any question, they can.
Because I want to know what is the use of scanf, and we write /n as a string in scanf.
Okay, this is again in respect to in the last assignment.
Yes, it does.
Okay, so basically scanf is about getting some input, right? It scans the stream. That's what the name itself says, right?
Right.
So whatever we are passing within that stream, we are simply getting it out of the stream.
Yes,
If we are passing means as a part of format specifier and arguments, if we are passing a variable, address of a variable, it will be stored in that variable. If we are not passing anything, in that case, it will be skipped. It will be simply flushed out. Yeah, please.
So is my screen is visible to you?
Yeah.
Yeah, in line, if I won't use scanf/n itself, the code was showing that like third test case was not passing when I used scanf and /n, then only third test case passed. So what is the reason for that?
And line number 14 you are talking about, right?
Yeah, sir. No, 12.
12.
After this scanf %s, I have to use scanf/n.
Okay. Okay, so this is similar to the same question, right? You initially asked, I guess, that when we have to take string inputs with spaces, correct? So what happens? The scanf definition is something which works on the format specifiers that we have used, right? As you look into the scanf statement that we have already written, you are passing some format specifier, and based on that format specifier, it performs something, right? So when you put it as %s, it expects a string, right? It is not expecting multiple strings in that case. So normally what we do whenever we print or whenever we put some input, right, we are expected to hit enter, right, new line character at the end of it. So that new line characters is considered as input to the next scanf statement. That is what happens usually. And to consume that or to flush that particular new line character, which is a kind of unnecessary before getting the next input, we use scanf with \n.
Sorry, sir. Yes, sir, I got your point, but my doubt is like test cases were passing, but sorry, that when we run the code, all the test case was showing pass, but after submission, it was showing one test case fail.
Yeah, so it depends on the test case, right? What exactly it is expecting as output, right? If there is a special character, there could be a possibility that there may be some additional non-printable character, right? Could be a white space, or could be a new line character, or could be an escape sequence, which is going into that particular variable that you are not able to see as a printed character, but is still considered in the input. So because of that, it could be failing. So if you look into the line number 12, right? So just after line number 11, why you are putting scanf \n? You are trying to consume \n, right? So that before the next input, we don't have that new line character into the stream. So similar to that, there could be some other characters you might be putting in that case. If it is possible for you to show, execute it and show me, we may talk about it. So you want to show something, or you are done?
I'll show, sir.
Okay. Meanwhile, any other question anybody has?
Because I have also used fflush instead of /n, but the program is running fine in that case also. So
that is file flush. F is for file, as I remember.
yes. So it is same as if I use scanf/t, then it will take /t. It will clear the buffer, right? That
Yeah, it is to flush the
tab.
buffer. Flush means just discard whatever is available in the buffer and don't use it.
Okay.
Zarina, one thing you can try to do, you can try to use the debugger once and try to figure out it.
Okay, sir.
Yeah,
Thank
or
you, sir.
otherwise, if you're not able to do that, you can just connect me and I'll help you.
Okay, sir. Thank you.
Okay.
Yes, sir. Thank you.
Any other question from anybody? No? Okay, Harsh, anything you want to add?
No, I think we have covered all the topics from array and functions. So that's all.
Okay. So I'll be giving some assignments. Maybe I'll upload it by tomorrow end of the day, and we'll notify in the group itself, the Telegram group, that assignments have been uploaded and you can proceed with them. I want to keep them simple, just to the basics, but still we'll see how it goes. Okay, if no questions from anybody else, then we are done. I hope we can close for today.
Okay.
Okay. Thanks,
Okay,
everyone.
thank you, sir.
Thank you, everyone.